Today we'll be looking at the cosine law. The cosine law is also used with non-right triangles, and it takes care of the cases where the sine law won't work. That is, where you don't have a pair of side and angle that you know both values for. There's only really two situations again that you can do with this. Number one, you know all the sides, but none of the angles. Well, obviously you don't have a pair there. Or, like the second thing here, we have two sides and the angle between them. So I don't know the corresponding side, I don't know the corresponding angle, I don't know the corresponding angle. I can't really use the sine law, I'm stuck with the cosine law. And in this case we say the 85 is contained, it's between the 25 and the 30. Cosine law, this big long formula here, you don't have to memorize formulas, I always give you formulas on your quizzes, your tests, your assignments, your exam, that kind of stuff. Just have to know when to use it. Non-right triangles, okay? The capitals, again, are angles, the smalls are sides. Big letters are across from small letters because they correspond to each other. There's two different versions of the cosine law. This is the first one. If I want to find an unknown side, I want to find side A. It's going to be across from the big A, and B and C are interchangeable, and you have to know both of those two things. And this is, I'd be using this if I want to find a missing side. Okay. If I want to find a missing angle, I'd be using a slight rearrangement of it. Again, I'm looking for the cos of the big angle, and it's going to be across from the small side. B and C are interchangeable. Just be careful in this case. It's really easy to put things in the wrong order, and it would make a huge difference. Okay. And if we're finding an angle here, also don't forget we're using inverses. When you get a picture, don't worry about the labels that are on the picture. You put the A's where you need them to be, and the B and the C where you need them to be. The A's are the most important thing. Okay, let's take a look at the first example here. Okay, I have no labels on it, so I can label it however I want to. I need the A's to be across from each other, and I have to be missing one of them. Okay, so my big A is my angle. The small a has to be across from it. That's where the x is. That's the part that I'm missing. So using the formula, we're going to use the first one here, the one that says a squared equals b squared plus c squared minus 2 bc cos a, because I'm missing a side. That's the part I want. That's how it's rearranged. I can plug in the parts and pieces that I have. A is x, b is 25, and notice that in this case they're definitely interchangeable because they're both the same size. But even if they weren't, b and c are totally interchangeable. So 2 times 25 times 25 times the cos of my angle. My angle is 30. Okay, I'm going to punch this all in my calculator at one time, exactly the way it looks. 25 squared plus 25 squared minus 2 times 25 times 25 times cos 30. If I do that, I get 167.47. Now remember, that's what x squared is. If I want to get x, I have to take the square root of that answer. And if I do that, I end up with 12.94. And I've solved the missing side. That's all I was asked to do in this one. That's one of the two kinds of questions we can do with the cosine law. The second one would be the one with the missing angle. Again, I can label this however I want to, as long as the A and the A are across from each other, and one of those things is my unknown. So I don't know that one. These have to be across from each other. B and C do not make a difference. You can call this B and C, or vice versa. It will not matter. Here we'd be using the second equation because I'm missing the angle. Just write it out so we can remember what it is. B squared plus C squared minus A squared over 2BC. Okay, so in our case, the cos of x, I don't know what that is. B I was using as 80. C was the 72. The A has to go at the end at 65. Make sure those all have squares on them. 2 times B times C. Okay, in a question like this, because I have a fraction which has multiple parts on it, I'm going to do the top as one section and the bottom as the second section. So I put all the top things in the way they look. I end up with 7,359. The bottom parts, 2 times 72 times 80, I'll get 11,520. Okay. Because I want to find an angle this time, I'm going to have to use an inverse. And I could divide this out, but because my calculator can handle large numbers, it will save me some time. I'm going to type in the inverse of whatever 7,359 divided by 11,520. And I'm going to use the brackets and use the dividing sign so my calculator does the work for me. rather than having to write out the big long decimal like we had to when we did the sine law. If I put in my calculator the way it looks, I'll get 50.3 degrees. And that takes us through the two types of problems you can do with the cosine. If you want to flip the page over and try the examples of applications, now would be a good time to do that.